Alzheimer's disease. Right now, people don't think they know what causes it. We don't think it's at all reversible. Some people don't even know what the early signs look like. What say you, Dale Bredesen, to that assertion?
Well, first of all, let's put it in perspective. Over 1 million people have died from COVID-19, and about 45 million of the currently living Americans will die of Alzheimer's disease. So it dwarfs the COVID-19 pandemic. It's just a little slower, as you know. But the reality is we're told all the time, we don't know what causes it. There's nothing you can do about it. We published a trial just a few months ago in the Journal of Alzheimer's Disease, in which 84% of the people actually got better. So we understand it.
Don't rush past that. 84% of people actually had a reversal of symptoms?
A reversal of cognitive decline, which we were the first to publish way back in 2014. And then we finally were allowed to do the trial, tremendous results. And we not only saw improvements in their cognitive testing, but we also saw improvements in their MRIs. So they actually had larger gray matter volumes, and their hippocampal volumes, which decline even with normal aging, declined less than with even normal aging. So this has not been widely recognized yet.
Sorry, that was going to skim over my brain for a second.
Yeah.
So with the protocol that we're going to go into here, people decline less than normal aging. So forget the fact that they're there because they have early signs of dementia, but you can actually slow even normal aging down.
Yes.
Okay, so Richard, we'll get into, I think, the punchline that you called the switch, which is a metabolic pathway that's really fascinating. It's been coming up a lot in my life recently. But first, just to orient people to Alzheimer's, I know a lot of people are going to be coming to this video because they're terrified of it.
Yeah.
They may have already been touched by it. They have somebody in their life. So speaking for myself, my wife's grandmother died of Alzheimer's. It is terrifying up close. And the thought of like, ooh, hey, I forgot where my keys are. Do I have Alzheimer's? You know what I mean? Like orient people around that. What are realistic early signs that people can look out for? And then we'll dive into how we start undoing this, how we can reverse that trend.
Yeah. So the reality is my generation, the old timers now, is the last generation that should fear Alzheimer's. It is literally becoming optional. And here's why I say that. If everybody, as they get to 40 to 45 years of age or so, would simply get evaluated and get on active prevention, then we could prevent this in nearly all people.
What does evaluation look like?
And the evaluation looks like three things. So what we call a cognoscopy. Just like we all know, right? When you turn 50, what do you get? You get a colonoscopy. Well, when you're 40 to 45 area, you should get a cognoscopy. And that's three things. Number one, a series of blood tests, and they're going to be related to what Rick's expertise, what's happening with your glucose and your fructose, what's happening with your inflammatory pathways. All the things that Rick's research touches on fits beautifully with our theory of what's driving Alzheimer's disease. So you get
really
that
fast breakdown for us. What would be a short list of things that we're going to look for in the blood? What do we care about?
Well, from my standpoint, it would be things like insulin resistance, measuring your plasma glucose or your fasting glucose level, and a thing called the HOMA test, which looks for insulin resistance. We'd be looking for features of metabolic syndrome. Do you have fatty liver? Do you have hypertension?
And all of this stuff is downstream of glucose, right?
Well, no, they kind of go together with the glucose. I wouldn't say they're downstream. I would say they're all occurring at the same time. So features of metabolic syndrome, which is obesity, diabetes, insulin resistance, all these are risk factors for Alzheimer's. And diet, there's certain diet food, so foods very high in sugar are associated with an increased risk for Alzheimer's. I'm not saying that you can't eat sugar. I don't want to demonize it, but
I do.
Well,
so I'm curious, why don't you want to demonize sugar?
Well, I mean, so it's true that sugar is we'd probably do better without it, but so many people, there's so many foods that have sugar. It's very hard to completely eliminate it from the diet. So the practicality of it, unless you go like on a keto diet, it may be hard to actually not eat some sugar. So it's really excess of sugar that's the biggest problem. I mean, like soft drinks, yes, we can demonize soft drinks. I agree with you. People should not be drinking soft drinks, but it's very hard to, even vegetables will have some sugar in them, and so I'm not saying that you shouldn't eat any sugar, but sugar and high fructose corn syrup are two major culprits that probably have a role in the cause of Alzheimer's.
Okay, I want to push on something that I said, which is that this is quote unquote downstream of glucose. So downstream may not be the right word, but everything that you've listed, to my layman's understanding, is going to be directly related to the amount of glucose that you consume. And you're being very delicate, which may be the wise stance, and maybe I'm the fool in this discussion. But all of this stuff is going to be related to the amount of glucose that you're intaking, to my estimation. Is that an uncomfortable assertion?
No, I think you're right, actually. I'm going to agree with you that, so there's a couple things. The first thing is that, yes, obesity, diabetes, metabolic syndrome, these are all risk factors for Alzheimer's. When we get to diet, sugar and high fructose corn syrup are clearly risk factors for Alzheimer's, but so are carbs, and so is glucose.
But carbs and glucose, to my layman's brain, are one and the same. If I eat carbs, I'm going to, minus fiber, I'm going to have a glucose response in the blood. And as somebody who wears a continuous glucose monitor a lot, I am startled by things like carrots that will spike my blood sugar as if I've eaten, maybe not a donut, but it's scary how close the response is.
Well, you're right. There's a range with carbs. With some carbs, especially if they have a lot of fiber, they don't raise the glucose as much if you have a glucose monitor versus a donut. And so there is this kind of scale. So the foods that particularly drive glucose up in the blood are things like bread, rice, potatoes, cereal, potato chips are like near the top. And anything that raises the glucose up, anything that raises that glucose up will get you into trouble, according to our work, on that could increase your risk for Alzheimer's.
Okay. So going back to the cognoscopy, so we've got the blood work, just went into some detail. I think you said there were 3 things. So that was one. What are the other 2?
And in the blood work, you also want to look at inflammatory status. So
what do you check for?
Yeah, so we typically check for HSCRP.
HSCRP? I've never heard of that.
So that's high sensitivity C-reactive protein. This is a pentameric protein, 5 of them together that come out of your liver when you have exposure to various pathogens and immunological things. So that's critical. And in fact, if you look at Alzheimer's as a disease, what is it? What is Alzheimer's? It's just a name. The big finding is it is related to 2 major things. Number 1 is your innate immune system. So this is the evolutionarily older part of your immune system that is a relatively non-specific phenomenon where it's saying something's wrong, things are bad, I've got to go into an inflammatory process and ultimately hand off to the adaptive system that now is more specific. These are where the toll-like receptors and things like that come into play. It's recognizing something's wrong. And amyloid is part of that. So the stuff that collects in your brain over the years when you get Alzheimer's is there because you are responding to insults. And then the denominator of this is energetics. So as your energy is dropping, again, coming back to the fructose story, which is why it fits so well with Rick's research, you're coming back to that in its cerebral blood flow, and it's your oxygenation, which is why people who have sleep apnea are at increased risk.
These are things I'm checking for in the cognoscopy?
Exactly. So you're looking at these pieces. So you want to know your pathogen status. Is your oral microbiome full of P. gingivalis, which is a specific bacterium, which gets into your brain, by the way, and your brain responds to that insult by making what's looked years down the road as Alzheimer's disease. So it's those 2 big issues we want to know. So we want to know your inflammatory status. We want to know your vascular status, which is why standard lipid panels, things like that. That's the cognoscopy. That's part 1, the blood. Part 2 is simple online cognitive assessment. You can do that in about 25 minutes, and it's going to test your memory, your executive function, your processing speed, things like that. 2/3 of the people who are heading for Alzheimer's, the first thing that goes is new memory. So it's laying down of memory. As you know, people will say, hey, where are we going tomorrow? Oh, we're going to, Aunt Jody's. And then 10 minutes later, they'll say, hey, where are we going tomorrow? And they're like, yeah, we're going to Aunt Jody's, as I told you 10 minutes ago. That's the kind of common early thing. But then we call that the amnestic presentation. About 1/3 of people present with the non-amnestic presentation, and that's typically executive function, planning, problems with calculating, having trouble figuring out a tip for the first time, things like that, having trouble working your iPhone or a new iPad or things like that. These are all kind of typical of the non-amnestic presentation. These are more, by the way, more parietal lobe functions instead of the usual temporal lobe functions, which are more on the amnestic side. So those are the things that typically come up, and you can pick those up early with an online cognitive assessment. And then the third part is MRI with volumetrics. You want to, if you have symptoms or if you're doing poorly on the testing, then you want to make sure to include an MRI, and not just a classical MRI. You want to make sure to get volumetrics. So you're looking at the size of your temporal lobe, the size of your hippocampus, the size of your parietal lobe. How does it match up with other people of your age?
Okay, so there are predictable shrinkage, for lack of a better word, that we would expect to see in certain regions of the brain based on your age. And so if you see something that's outpacing your age, then now we've got a problem.
Exactly.
Okay.
So I would like to add something here. So, when he talks about the cognoscopy, when Dale does, I can point out how this sort of fits in with Alzheimer's in general. So, originally, when people think about Alzheimer's, they think of amyloid plaques. They think of these tau protein neurofibrillary tangles. These are characteristic histologic findings if you actually do an autopsy on a patient with Alzheimer's. The brain shrinks, there's neuronal death, and there's these classic findings. And that's why for years everybody was calling this a disease of amyloid plaques. We're going to treat those amyloid plaques. We're going to try to either dissolve them or prevent them. And all these treatments came out, and most of them don't do very much. There are some that may have a little bit of benefit, but we're not really winning the war. And so that made people look for the next level. You know what? Maybe it's not the amyloid plaques. Maybe it's something that occurs before that. And I just want to point out that Dale's cognoscopy testing is looking for those things that are occurring early. And there's really three basic areas, which he just talked about. One is metabolic. Do they have insulin resistance? Are they overweight? Are they eating foods that we know are not healthy for you, like high glycemic carbs, a lot of sugar, a lot of salt? That's also associated with. So one is metabolic. And then and insulin resistance and high glucose is a major part of it, because in the brain of patients with Alzheimer's, one of the earliest changes is insulin resistance of the brain.
How do you test for that?
Well, I know how to do it in a mouse.
Is it destructive though?
So what happens is the brain, there are regions of the brain that that use insulin to help take up glucose. Okay, so insulin is a hormone that helps cells take up glucose as a fuel, and the classic insulin-sensitive tissue is the skeletal muscle. And the skeletal muscle uses insulin to help take glucose into the muscle to give it fuel. In the brain, we used to think the brain was largely insulin insensitive. Glucose can go into the brain freely without insulin. Well, it turns out that's not true. There are regions in the brain that use insulin to help bring in the glucose. And those areas become resistant to insulin in early Alzheimer's. And so you can do things like PET scanning and things like that to look for glucose utilization. And if there's an impairment in glucose utilization, in other words, the brain's not metabolizing the glucose well, you can actually measure it. And so metabolic is one of these three characteristics that you're looking at. And the other two, just real quickly, is the second one is inflammation. And systemic inflammation is now known to be a major risk factor for heart disease. Paul Ritger, brilliant scientist at Harvard, has done all these work where he measures C-reactive protein. This is the same test you're doing, the HSCRP. If it's more than 3, normal is like less than 1. If it's over 3, it means that you have inflammation. You have systemic inflammation. You may not have a fever. Your white count may be normal. You may feel fine, but there's low-grade inflammation in your body. And that's also seen frequently in people with metabolic syndrome. So the CRP is like the perfect test. Paul Ritger believes that everyone should have that test done. If you have an elevation in CRP, it increases your risk for heart disease. It increases your risk for hypertension. It increases your risk for kidney disease. And I believe it's inflammation is, well, we know that inflammation in the brain is one of those early findings of Alzheimer's. And I don't know for sure, but I think C-reactive protein, has it been looked at as a risk factor for Alzheimer's?
Yeah.
And it is.
So,
right?
anything with increasing inflammation.
So that in the cognoscopy score that Dale's using, he's looking for inflammation, which, because we know inflammation in the brain's an early finding. He's looking for metabolic changes like insulin resistance, because we know insulin resistance in the brain is occurring. And the other one is energy status. Energy, there's really two kinds of energy. There's the energy that we actively make, and we're using it so that I can talk to you and you can talk to me, and we can, if I need to escape, I'll run out.
Let's hope that doesn't become necessary.
Let's hope. But that energy is ATP. That is the currency. That is what our bodies make and uses as the way we use energy. We use ATP. And that's the active energy. But there's also stored energy. And stored energy is fat. And so when you eat food, which is a calorie source, we make energy, and some of it is ATP and some of it is fat. And, typically we try to refill our ATP, and then the extra goes to fat. And this is how normally it works. And so we usually have good ATP levels. But what has been discovered in Alzheimer's is that ATP levels, the energy in the neurons is low. Early on, you can show a drop in ATP, and it gets worse as Alzheimer's progresses. So our brains don't, the neurons they're not taking glucose up as well, which is the fuel, and they're not making as much ATP. So the brain goes into a low energy state.
Exactly. And Tom, you mentioned earlier, how do you check in a human if you've got insulin resistance in the brain, as Rick was saying? And some very nice work from Professor Ed Getzel out of UC San Francisco showing that if you look at neural exosomes, so you can literally look at tiny fragments of cells. These are about 100 nanometers, little fragments of cells that break off from cells throughout your body. In the brain, these actually traffic through the blood. You can isolate them, and you can actually measure the insulin resistance. He's published this a few years ago.
You can do that in a blood test?
You can do it in a blood test. Now, this has been a research tool. It's coming online, but it's not yet commercially available. But you can. So
I can't go to my doctor yet.
You can't go to your doctor yet and ask for that, but it's coming.
Interesting.
But the PET scans probably
PET scans, yeah. And
that's
so
the way to do that.
Exactly, and it goes exactly with what Rick was saying. What is the signature for Alzheimer's? When we as neurologists look at a brain, you see temporal and parietal reduced glucose utilization. And so, it fits perfectly with this notion that you are dealing with an insulin resistant state, and the brain is simply not using this. But it's also, interestingly, not using the only other fuel it can use, which is ketones. So you have a real energy emergency state when you have cognitive decline. You're not able to use the glucose because of the insulin resistance. You actually can look at differences in signaling. But you're also not able to produce and utilize ketones because one of the things that prevents you from making ketones is a high insulin level. So it's kind of worst of both worlds.
Yeah. Okay. So let's recap where we are, because I think that this is really important. And I think this is going to take us into now needing to talk about the switch and what's actually going on here. Okay. So as somebody who for a very long time, I was hyper inflamed. I didn't understand that. I always thought it was kind of funny, but you could take your fingernail and write your name in my skin, and my skin would just welt up. And my dad had the same thing, and I obviously didn't realize, hey, this means you're going to die young. I was not that sharp, unfortunately. And as I got older, though, and I didn't put two and two together, I started having chronic wrist pain. And I had burn marks on the back of my hands for years because I was icing them so often that it was like leaving this little burn mark. And I then met Peter Attia and Dom D'Agostino, and they said, oh, dude, you've got to be eating fat. Like, this is crazy. Because I was doing what I'd now call rabbit starvation. Basically, the vast majority of my calories were coming from protein. I was intaking as little fat as humanly possible because fat makes you fat, right? So I was convinced. And I'd gone low carb years before that. So I thought, well, I'm low carb. My diet is clean. I assumed my wrists were like a genetic problem. And when they said, hey, you need to try going to being able to be metabolically flexible and produce ketones. So try a high fat diet and stay low carb, but actually go moderate protein as well. Let's see. Now I hated it because I got keto flu. I did not do it well. But my wrist pain went away in like 3 days.
Did you measure your uric acid?
I didn't. I don't even think I'd heard of uric acid at that point, unfortunately.
Yeah, because a very high protein diet can raise uric acid. Now, normally we don't think of the uric acid as being that much of a problem, but when you're on a keto diet or when you're on a low carb diet, but it can, when it gets high enough, it can cause inflammation, like big time. And it can cause gout.
Yeah, gout I didn't have.
But it can present like with wrist pain, knee pain, ankle pain without having a complete inflamed attack. Because when you're on a keto diet or low carb diet, the ketones actually suppress inflammation to some extent. So you can have kind of like a pseudo, you have gout, but you have a high uric acid and you may have problems with it, but you may not actually manifest full gout because the ketones are anti-inflammatory.
Okay, so let me press on that. So are you saying that by being on a ketogenic diet, which I will define as a diet that elicits a 0.5 millimolar or higher ketone distribution in the bloodstream, so you're on a diet that produces that, I could still be high in uric acid?
Yeah, so ketones there's this really interesting aspect. So uric acid is generated from sugar, eating fructose, which is like in table sugar, and it's also in high fructose corn syrup. So you can get a high uric acid from eating carbs, that contain fructose. But you can also make uric acid from protein. And it's not as much of a problem if you're on a low carb diet, because one of the things uric acid does is it acts to convert glucose to fructose. It's like it can generate fructose in your body, but
I didn't realize until researching for this episode.
But if you're on a low carb diet, you don't have that much glucose around to convert to fructose. So the uric acid isn't quite as dangerous in a person on a low carb diet. It can often go up though to 8 or 9 or even higher. But there are many cases of people on low carb diet who will develop gout. Interestingly, it's not usually as serious an attack of gout as, and when a person's on a normal diet with carbs and stuff. And that's because the ketones are anti-inflammatory.
If you had to ballpark me, how many grams of protein, so I'm about 185 pounds, how many grams of protein would I have to eat to be in that state? Because my gut instinct, and you gentlemen are going to strike me dead if I'm wrong here, but my gut instinct is you could never eat enough protein to be considered high protein and stay ketogenic. Like you'll get kicked out. If I eat too much protein, I'm out of ketosis.
Yeah, because the protein, some of it gets converted to glucose.
Yeah. So am I crazy, or is my vision of high protein like so ultra high as to be nonsensical?
Well, so it turns out that when you're on a ketogenic diet, the uric acid goes up for two reasons. One is the high protein, but the other is the ketones actually block the excretion of uric acid. So it goes up from both, unfortunately. So it's very, very common for people on a keto diet to have, a uric acid of 7 or 8 or 9.
Whoa!
But then over several months, it will tend to come down. It will tend to come down.
Do you consider a ketogenic diet healthy or unhealthy?
I think that in general, they're fantastic diets.
Even though uric acid can get that high.
Yeah, so this has been the paradox because uric acid does go up.
And sorry, for people that don't know about uric acid, give them a quick primer, because I'm reacting like it's the devil's brew. So give people a quick primer. I think of uric acid as bad, partly because of your work. So give people a primer on what uric acid does.
Yes. So uric acid is a substance that's in everybody's blood. We all make uric acid from when we break down energy or when we break down DNA or RNA. It's basically nucleic acids that when they get broken down, they make uric acid, and then we have to excrete it. Humans have to excrete the uric acid through the kidney or the gut. Other animals actually can degrade uric acid because they have an enzyme, but we lost that enzyme 15 million years ago, and we had a mutation, and I think it's actually plays a role in some of the problems we have today. But anyway, that as a result, uric acid tends to be higher in humans because we don't degrade it, and we have to excrete it through the gut or the kidney. So like a uric acid in a mouse, or maybe a level of 1, and the normal level in a human is around 5. So we have a much higher level. And when you go on Western diet, it actually goes from about 3 on a hunter-gatherer diet to about 5 on a Western diet. And then when it gets to 7, which is when you start eating a lot of sugar, shrimp and beer, there's sounds good to some people.
Sugar, shrimp, and beer. It's quite the
but
diet.
Anyway, when you start eating a lot of foods that can make uric acid, then what happens is because we don't degrade it, it can get up to 7 or higher. And once it gets up to over 7, it can cause the disease gout. And gout is this really painful disease. It affects maybe 9 million people in the U.S. Wow. And it's an arthritis, and it usually causes red hot, tender joints and systemic inflammation. The C-reactive protein goes up. You can have a low-grade fever during an attack. And even after the attack, most people with high uric acid show evidence of systemic inflammation. Their C-reactive protein's frequently high. It stays high, and the reason is because these attacks are from crystals of uric acid that deposit in the joints, and they don't really go away. So the attack goes away, but the crystals are still there.
Ooh.
And they cause this low-grade inflammation. Recently, we discovered that they can also deposit in the blood vessels. And there was a paper in JAMA showing that 70% of people with gout have some urate crystals in their aorta or their coronaries, and it correlates with increased risk for heart disease. So Paul Ritger has been saying, inflammation is a major cause of heart disease. And the truth is that high uric acid can cause inflammation, and even when you don't have an attack of gout. And so, but what's interesting is if you go on a keto diet, so a lot of uric acid comes from the sugar, from fructose, and uric acid actually is made when you metabolize fructose. You make uric acid, but then uric acid helps convert glucose to fructose in the body. So it's like a cycle, a vicious cycle. So when you go on a low-carb diet, you break that cycle to some extent because you're not eating so much carbs. But the problem is ketones block the excretion of uric acid, so your uric acid can still go up. So a real problem is that, a high uric acid, is associated with heart disease. It's associated with obesity and diabetes. But the complicating factor is that keto diets, which generally helps block obesity and diabetes, can still raise uric acid. So the question is,
didn't you say that ketones block the secretion of uric acid?
Yes,
so how is it going up if ketones are blocking it?
So ketones block the excretion of uric acid in the tubules of the kidney. So you can't get rid of the uric acid, so it goes up in the blood. I see what you're saying. It stops us from getting it out. Yes, it stops us from getting it out. And it usually only lasts, for the first few months. But there are some people who continue to have a high uric acid. And when you say that you had evidence of inflammation, high uric acid causes inflammation. It causes pain in the wrist. So I was just thinking that maybe you were one of those people who had a uric acid of 9 on that diet. And the issue is, though,
remember the ketogenic diet is what caused my inflammation to go away.
Right.
Yeah. So I had it during my rabbit starvation phase.
Okay. So ketones are anti-inflammatory.
Mm-hmm. So
several people that I've collaborated with are looking at, for example, Ben Bickman. Maybe you've interviewed him. So Ben's doing some studies to show that when the uric acid goes up on a keto diet, that it's fairly innocent, because the ketones are anti-inflammatory and can block the pro-inflammatory effects of uric acid. So uric acid is mainly this thing that causes inflammation, and ketones block inflammation. So it's sort of like the way to stop it. So your uric acid can go up, but if you're on a keto diet, you may not suffer from the inflammatory effects of uric acid. So that's what we're thinking. But there are many cases of people who still get attacks of gout on a low carb diet. I don't know so much about a keto diet, but so that it's a balance of a good guy, the ketones, and a bad guy, the uric acid. And so which one dominates could be important. But in general, a low carb diet and a keto diet are diets I recommend in general.
Aggressively.
Critical distinction here. So many people get this wrong. A keto diet versus a plant-rich keto diet. It makes all the difference. So for brain health, you want a plant-rich ketogenic diet with appropriate periods of fasting. So you want to get the ketones up. You want to have the low-carb diet, but you don't want to have just a pure meat diet.
Why is that? So I'm ultra high. I get most of my calories from meat. So if you're going to change my life right now, I want to hear about it. So what is the difference? How does it work mechanistically?
Let's change your future for the better. Absolutely.
I like it. Let's do it.
So first of all, as you probably know, there are now increasing reports coming back from people because of this carnivorous approach with ketones who are ending up with vascular disease and ending up with heart attacks and strokes.
That's controversial? Or like when you go and talk to somebody who's hardcore carnivore, obviously they paint a very rosy picture. I will say anecdotally, and yes, I understand the limitations of anecdotes, but anecdotally, every time I've tried to go primarily plant-based, I don't feel good. So now I've never looked at, maybe I'm just doing it wrong. Maybe I just need to supplement, but I'm always skeptical of anything where I have to supplement to get where I need to be.
Yeah.
So what is happening when I intake meat? What's happening? Or if it's meat isn't an additive problem, it's you're missing something. What am I missing, or vice versa?
So I think it's a good point. The pure carnivore diet, where that really works well, is for people who have a tremendous amount of inflammation. And whether it's related to the lectins that Steve Gundry likes to talk about, or whether it's related to something else that you're responding to, that's personal. It may be different for each person. But if you look, for example, at apoe4.info, this is 3,500 people who are ApoE4 positive. This is a common risk factor for Alzheimer's disease. About 75 million
Americans. Because it's
Americans.
pro-inflammatory? Do we know?
Yes, because, for other reasons as well. It doesn't allow you to get rid of amyloid as well. But yes, the predominant issue there is, and of course, as Rick will tell you, it also has to do with fructose. Yeah. But it is a pro-inflammatory gene. It is at the primordial ApoE, and it's interesting because it was different in our ancestors, so that the simians, as we became the hominids between 5 and 7 million years ago, The initial was we were all ApoE4 homozygous. For 96% of hominid evolution, we've all been ApoE44, which today confers about a 70% lifetime risk for Alzheimer's. It's it's the dominant way. We've got 75 million who have a single copy in this country. We've got about 2 million, about almost 7 million, 2% of the population, in other words, that has 2 copies. And they're at very high risk for Alzheimer's disease. And so the point here is that they have to be careful about a carnivorous diet. Because they tend to jump up their LDL particle numbers, they tend to jump up their triglyceride to HDL ratios, and they're at high risk for heart attacks and strokes. Now, again, if you're going after inflammation and you don't have issues with your vascular status, then it's probably fine to have a carnivorous diet. But for most people, and certainly for Alzheimer's disease, the phytonutrients, just take one of many polyphenols alone. High polyphenol associated with lower Alzheimer's disease. Take the risk. We've all heard so much about lecanemab, which was supposed to be this miracle drug. It's the only one of the anti-amyloid antibodies that seem to have an effect. It doesn't make you better. It doesn't keep you the same. It slows your decline in Alzheimer's in the early stages by 27%. Wow. Now, what does better than that multi-billion-dollar drug? Extra virgin olive oil alone did better than lecanemab.
Can I add that to a high meat diet and get the same effect?
You can certainly add it to a high meat diet, but you have to remember that you're missing the polyphenols, you're missing the phytonutrients, you're missing the high fiber. Now, what do you do for fiber?
Well, so I do eat vegetables. Okay. It's just that I would say 65 to 70% of my calories come from eggs and animal protein. I guess that is animal protein. Meat, and then the remaining 30 to 35% is vegetable matter.
Okay, so at least you're staying away from the high carb, which is great.
I don't touch carbs. My diet is very what I call clean. I'm always looking to improve, but so I eat a lot of eggs. I eat a lot of red meat. I eat a lot of pork. I eat a lot of fish. Beef, if I didn't ever say that. So those are my mainstays. And then I cycle through maybe 10 different vegetables.
Okay.
And lots of extra.
And what are your ketone levels?
Lots. I'm not on a ketogenic diet now. Okay. So I can feel, though, when I click in, probably I could tell you if I hit 0.7. I might miss a 0.5, but because I intermittent fast a lot.
Yeah.
And I tracked religiously my intermittent fasting over an 18-month period, and it came out to be about 17 and a half hours. And that includes weekends, holidays, everything, just over the whole time, about 17 and a half hours. So, I mean, some days I'm going 19, 20 hours.
Right.
So at that point, I'm going to kick over into ketosis. So I'd be at a 0.5, 0.75, somewhere in there, and I can feel that. Yeah. So I would say right now I can tell you I'm not in ketosis just because it's a weekday, so probably only did 16, 17 hours.
Great point. And do you know your ApoE status?
I don't. So this is, in fact, I want to ask you more about this. So if for however much of our evolutionary past we were double ApoE4, and
96%
all
of our
was
evolution.
well. So what has changed? Now, is it diet? Is it some other genetic mutation that makes ApoE4, or is it that we live longer that makes that such a problem? Why aren't monkeys having an issue with this?
So interestingly, monkeys have a different ApoE. And there were multiple mutations between the chimp, for example, between our common ancestor and the first hominids. And so we picked up a specific mutation, which is an arginine actually instead of a threonine, and you have what Professor Robert Maley, who discovered ApoE, has termed a domain interaction. So if you have ApoE4, your ApoE looks like columns on a house. Basically, it's held together because you have a positive charge interacting with a negative charge. However, then just about 220,000 years ago, so relatively recently in terms of overall evolution, ApoE3 appeared, and then just 80,000 years ago, ApoE2 appeared. And these are less pro-inflammatory. So guess what? You're not as good at fighting off, you eat raw meat that's got microbes in it, you're not going to be as good at fighting off the infections.
With an ApoE3 or 2.
Exactly. And also you don't do as well with starvation. Again, comes back to Rick's work with fructose and with this approach that you're taking in periods of starvation. But it gives them less inflammation, so that they tend to live a few years longer and they have a much lower likelihood of Alzheimer's disease. And what's changed is the way we live. What's changed is what we're exposed to in our homes with mold and mycotoxins, the sugar that we're eating, just Rick's research. These are the things that have changed. We are not. We don't have the same sort of intake of plants. We do have a lot more carnivory. So all these things have changed. And this is why, you may be in perfect shape, and you can certainly check that out with a cognoscopy. See where you stand with your metabolism, with your vascular status. And I don't know if you've looked at your carotids or you've looked at your...
but it's been 7 or 8 years.
Yeah. So if your vessels are looking good, and you've probably seen these pre-nuvo scans, you can look now your whole body to see if you have any early tumors. You can look to see whether you have early changes with your microvascular status in your brain. These are good things to know.
Okay, so we have inflammation obviously playing a huge role. Your diet is really particular. What I want to start getting into now, let's bring it all together with the switch, why this matters, how it ties to Alzheimer's. So what is the switch?
Yes. So the switch refers to a biologic change in which an animal suddenly starts to gain weight, become insulin resistant, and develop features of metabolic syndrome. It's an actual biologic change. So normally animals try to maintain their weight at a regular weight. If you feed them extra food, if you put a tube down their mouth and force feed them, and then you take the tube out, they'll go right back to their normal weight. If you fast them for 2 months and then you stop fasting them, they'll go right back to the weight they should be at that time of the year. I mean, it's amazing. Animals regulate their weight beautifully. And we probably did too, but we're not doing it now. And when we were trying to figure out, what triggers this change, and it's most noticeable in like animals that are preparing for hibernation or for long distance migration. The bear will maintain its weight during the summer. It can eat more one day, it'll eat less the next day. It just maintains itself. And then about 8 weeks before it hibernates, suddenly it changes its behavior. It gets hungry all the time, thirsty. It starts foraging for food. It becomes insulin resistant. It starts eating a lot more than it normally does. It can gain 10 pounds a day.
Whoa.
Yeah. They have a contest to take a picture of the fattest bear on the internet and in the fall, because they get really, really fat. These hibernating bears, before they hibernate, they want to put on that fat. And then when they hibernate, they will not eat, they'll go to sleep and they'll not eat for like 6 months. They won't drink water, and they use that fat to produce energy. That they live off their fat. So fat is a good thing in nature. My book, Nature Wants Us to Be Fat, talks about this. But the fat, when they break down the fat, it isn't just the energy that's produced, the ATP, but the fat also produces water. Mm-hmm. So when you break down fat, you're producing water. So this switch is the switch going from a point where you're regulating your weight till suddenly you're gaining weight. And it was all meant to be a survival mechanism to help the animal in preparation for a time when there may not be food around. And so the question is, what triggers that switch? And it turned out, from our work, we were convinced that the major trigger is fructose. And fructose is a sugar. It's in fruit and honey, which we think of as healthy, but it's also in table sugar. It's in high fructose corn syrup. In table sugar, half of the table sugar is fructose and half is glucose. And we eat a ton of sugar and we eat a ton of high fructose corn syrup. So we get a lot of our fructose from added sugars. Maybe 15% of the average American diet is sugars. Oof. But these we also can make fructose, as I mentioned earlier. And we can make it in every organ, including the brain. And the thesis for what causes Alzheimer's is that it's fructose production in the brain that's causing Alzheimer's. And you make fructose from glucose. That's the only way. You can only make fructose from glucose. So when you're on a high-carb diet, you're making fructose all the time, and especially high glycemic carbs, because when the blood glucose goes up, that really triggers the conversion to fructose. You got more substrate, to convert the glucose to fructose. As there's more glucose, there's going to be more fructose made. And and salt turns out to activate that conversion as well. So it turns out that salt can increase fructose production. And red meats have been associated, these umami foods, they can help convert the glucose to fructose. And so red meats, salt.
Why?
Yeah,
why red meat?
Because they contain purines that raise the uric acid, and the uric acid can help convert glucose to fructose. So you got two major mechanisms. So when you make fructose, you make it from glucose. So high carb diets are, a big way to get it. But then salt and red meat can trigger the conversion of glucose to fructose. Now, I'm going to answer, your question: is red meats okay for you? And you're not on a high carb diet. So, red meats are associated with Alzheimer's. There are a couple of papers that show increased red meat intake is associated with Alzheimer's. That's scary for people who are on a carnivore diet, but it may not be true for people on a carnivore diet, because according to our work, it's the fructose that causes the problem in the brain. It's not the red meat. And the red meat makes uric acid, which may not work very well to convert glucose to fructose on a low-carb diet, because you don't have a lot of glucose around. Now, if you're eating a lot of protein where you're making enough glucose, maybe that becomes a problem. But in general, this might answer your this issue of, is red meat bad? Plant products are probably better in general for, on the regular diet. But if you're on a carnivore diet and you're not eating a lot of carbs, you may not have that. It's conceivable you may not have that problem. Probably don't.
Very interesting. And if I remember right, salt is the same way.
Yeah.
So if you're eating a lot of salt,
right,
and you have glucose in your system, then that's going to be converted. But
Absolutely.
if you have salt but no glucose, then
Absolutely.
the odds are it won't.
Yes,
There's nothing to transfer.
Absolutely. That's why salted French fries and salted pretzels and salted potato chips are so bad, because the carbs, the potato chips gives you the glucose, the pretzels give you the glucose, but the salt helps convert that glucose to fructose, and it will do it in the brain. We have given high salt diets to animals, and we can show an increase in fructose production in the brain. And there's a Dr. Sherwin at Yale who gave glucose and just infused glucose in people. And if he brings the blood glucose up, we know it gets converted to fructose. And he showed in people that brain fructose levels go up. You can just see it. Like after about 40 minutes, an hour, the fructose levels start going up in the brain. That is scary, because our work suggests that could drive Alzheimer's. It's been known for a long time that diabetes increases the risk for Alzheimer's. But if you can control your diabetes well and keep that blood sugar low, you're going to reduce your risk significantly. I don't think it's diabetes that causes Alzheimer's, but the high glucose converts to fructose.
And I'm just going to say one thing here. When you talk about Alzheimer's, I think that's critical. You're also talking about mental performance. So the things that we do to prevent you from getting Alzheimer's make you sharper. So it's not, you're not just talking to people worried about Alzheimer's. And then the third piece of this is that you're also talking about people who've had COVID-19, where you know that so many people get brain fog. And it turns out, unfortunately, that many of the mechanisms are in parallel. And it's already been shown that people who developed COVID-19 are at increased risk for developing Alzheimer's.
Whoa.
So the things that you're talking about today are for people worried about Alzheimer's, or for people who want to think better on a day-to-day basis, and for people who've had COVID and want to make sure that their brain fog doesn't ultimately slip into degeneration. So this is a widely applicable situation you're talking about here.
Okay, that's super terrifying.
Yeah, and I think that you found in your studies that insulin resistance is a major risk factor for Alzheimer's and counts for maybe half of the patients? Or
Very common, of course, metabolic syndrome. There are about 80 million Americans or so who have metabolic syndrome. It's incredibly common, and that includes insulin resistance. So it's just what you're saying. The way we live, the things we're exposed to, the foods, the ultra-processed foods that we're eating, these are all what are colluding to give us such a common way to die through Alzheimer's. About 15% of the population dies from Alzheimer's. And
That's
as I said,
insane. I had no idea it was that high.
Yeah. So the fact of the matter is, it should be optional. And for your generation, you know, the vast majority of people should be able to avoid this problem through the very things that you're talking about today.
So that brings us to fructose. We know we're eating a ton of it. We know we're converting a ton of it, given the things that you just taught us. Tie fructose for me to the bear. It certainly was between the lines in what you said, but I'd love for you to make it explicit. The idea of a yearly cycle, for anybody that's ever heard, like, I eat fruit, but only in season, I was always like, what does that mean? Yeah. So walk us through that.
So you know, we think of fruits as healthy, and in many respects, they are healthy, and I recommend fruits. But if you eat a ton of fruit, and I mean a ton, you can get a lot of fructose that way. So fructose is the sugar in fruit, and bears in the fall will start eating thousands of berries, and they love honey too, and they search it out, but it's mainly berries that they eat. They can eat 10,000 berries in a 24-hour period. People have counted the seeds in the scat. And anyway, when you eat that much fructose, you can activate the switch. And it's not the fructose that makes you fat, it's that fructose makes you hungry. And fructose, and it causes a thing called leptin resistance, where you can't control your appetite. And so
I know there's in the paper, you guys break them all out. So you've got hunger, you've got leptin resistance.
Yep. Foraging. It stimulates foraging. So fructose does.
Is that different than hunger?
Yeah. So hunger is you're searching. I mean, hunger is you want to eat, but foraging is the process of going out and searching for the food. We'll talk about foraging in a bit, because it's the key insight that led to this hypothesis.
Let's see that coming. Okay, so hunger, leptin resistance, foraging. It's also decreasing your ATP production.
Yeah, so what happens, to break down the switch, the first thing is it stimulates hunger and thirst, both. And it stimulates foraging, where you have to go out and search for food. It also stimulates food intake, and actually it blocks satiety, this feeling of fullness, so that you keep eating.
That's the leptin resistance, right?
So you eat more than you should. It blocks the break within the cell. It has this unbelievable trick that it does. And the trick it does is that it lowers the ATP. You're eating calories. You think your ATP levels should go up. But remember, energy is both stored energy and active energy. And what it does is it stuns the mitochondria. The mitochondria are the energy factories that make ATP. So they turn the mitochondria down, and ATP production by the mitochondria goes down. So where does the energy go? It has to go to the stored energy, which is fat. And it blocks the breaking down of fat to replace the ATP. So the ATP levels stay low for quite a while. Like if you drink a soft drink, I can do an NMR of your liver and your ATP levels are going to fall and they're going to stay low for a while until they eventually recover. And during that time, it stimulates hunger, foraging, and it's blocking the oxidation of the breaking down of the fat. So the fat accumulates. Calories are going into the fat, but you're not breaking it down. So the fat stores go up. ATP levels stay low. The low ATP levels are like this alarm signal. Hey, I don't have enough energy. I'm in a low energy state. I'm going to eat more because my body's telling me that I'm in a low energy state. And so your blood pressure goes up to help maintain circulation. Pressures go up in the kidney to help facilitate excretion because it thinks that you're under attack. I'm under attack. And that's what fructose does. It's the only nutrient that lowers ATP in a cell. All the other nutrients do increase the ATP. But glucose is still the culprit. You're right, because what happens is when you eat fructose, very little gets to the brain. But fructose and glucose, either of them, stimulate fructose production in the brain. So although if I label a fructose molecule in this sugar and I eat it, most of it gets removed by the liver and the gut and the circulation. Very little of it gets to the brain. This was, the trap. Yet fructose production goes up in the brain when you eat sugar, and it's from both the glucose and the fructose. And the glucose is the more important one, I think. Actually, I don't know which ones. They're probably both equally important, but you're right. When the glucose levels go up and when you're insulin resistant, you are making fructose in the brain.
Talk to me about the insulin resistance. In the paper, this plays a pretty fascinating role in terms of what's going on. Why would insulin resistance ever be evolutionarily advantageous?
Yeah, so it's pretty complicated, but I'm going to break it down to two things. So first off, there's the insulin resistance in the muscle. So and then I'm going to talk about insulin resistance in the brain. Okay, so when you eat fructose, you want to. It sets off an alarm signal that says, "Hey, I'm under attack," and so and I need to get food, but I need to conserve my energy. So the way the body does that is it stimulates foraging, which requires energy, right? So you have to go out and find the food. That's going to cost energy. So it drops the resting energy. The resting energy metabolism, when you're not doing anything, drops. And so animals will kind of huddle. They'll kind of like become couch potatoes, because when you're not doing anything, you kind of go to a lower energy state. And this helps conserve energy. So it's all about the animal thinks it's running out of energy. So you when you're not exercising or you're not foraging, your energy goes down. And when you are foraging, you can maintain the energy you need. Okay? And insulin resistance has a role in dropping that resting energy because your skeletal muscle uses a lot of energy. And when you become insulin resistant, the muscle's not taking up as much glucose because it requires insulin to take up the glucose. So you become insulin resistant, you lose the muscles kind of going into a low mode state, low energy mode. And unless you're like foraging, and then it will use what it's got. And then also the glucose levels will go up in the blood because there's less going into the muscle. And there's certain regions of the brain that don't require insulin, and they can use that glucose to help think. And thinking is critical if you're going to survive. If you go into energy, drop your energy needs, you still want to be able to think it through. So that's how the systemic works. Now, in the brain, it's an amazing mechanism, and that is that fructose does also causes insulin resistance in the brain. And if you give fructose to an animal, remember the three things that we talked about with Alzheimer's? The earliest one is inflammation. Fructose, if you give fructose to an animal, they get inflammation in the brain in the same sites, the hippocampus, which is the memory centers. The second thing is if you give fructose to an animal, they get insulin resistance in their brain that you can prove. And they also get mitochondrial. Remember how fructose blocks the mitochondria and suppresses the ATP? You see that when you give fructose, and it's in the same sites where Alzheimer's occurs. So the three characteristics of Alzheimer's, which is low energy, low ATP, mitochondrial suppression, insulin resistance, and inflammation, these are all what fructose does. Not just systemically, but when you give fructose to an animal, it happens in the brain. And if you raise glucose, fructose goes up in the brain, and you see that.
You can reboot your life, your health, even your career, anything you want. All you need is discipline. I can teach you the tactics that I learned while growing a billion-dollar business that will allow you to see your goals through. Whether you want better health, stronger relationships, a more successful career, any of that is possible with the mindset and business programs in Impact Theory University. Join the thousands of students who have already accomplished amazing things. Tap now for a free trial and get started today.
So that's really interesting. So why would we want the brain to become insulin resistant? And this was the twist. And thank you, Dale, and thank David Perlmutter and our discussions with other neurologists as well to try to understand this. But it turns out that foraging is a specific behavior that requires activating some regions of the brain and inhibiting others. It isn't like, hey, I'm just going to go out and, find a deer. It isn't quite like that. So to forage, you actually have to develop exploratory behavior. It requires you to go into areas you may never have been. So there's an exploratory component. You have to be able to move fast, so that your locomotor activity, you have to just keep going. You can't take too many breaks because you got to find that food. You have to have good visual cues, so that if you're looking around and you see a piece of food, something that you can eat, you catch it. And the visual cues have to light up. Some people, if there's a piece of cake in the room, you find it immediately.
Then I have that activated at all times.
Right? Yeah, I know where those chocolate cookies are. Anyway, so the visual cues have to, and then there's certain regions like you have to decrease your self-control. You don't want a lot of self-control. A lot of our cortex is involved in self-control.
This is terrifying.
The frontal cortex is, it tells you, I don't want to go into that cave because there could be a lion in there. But you don't want to have that much self-control, because if you're trying to find food for your life, you've got to be brave enough to go in there. So bravery, impulsivity, short attention. You have to scan things around. You can't deliberate. If you deliberate and focus on one thing for a long time, you're going to miss everything. So it turns out that there's regions of the brain that are important for attention, deliberation, self-control, impulsivity, and certain regions of the brain. There's this one region of the brain that you stimulate it and animals forage. And that, if you give fructose to an animal, or fructose, this is involved in foraging. If you give fructose to a human, they've actually shown that the blood flow to the frontal cortex goes down. Blood flow to the temporal and cortex goes down. Blood flow to the hippocampus goes down. It's trying to reduce the activity there, and also it's associated with, impaired glucose utilization in these areas, and insulin resistance in these areas. So the fructose is working to create insulin. So there's less fuel going in. There's less fuel utilization. It saves energy. 20% of our energy is from the brain. So this is another way to conserve energy, but at the same time, it's reducing our self-control, allowing us to be more impulsive, and allowing us to forage.
So great state to be in if temporarily you need to go be in beast mode, get as fat as you can because you're about to hibernate, but really atrocious if we leave that switch on all the time, which is what we're doing now. So Dale, walk me through. So we have this evolutionary advantage, which allows us to survive this seasonal cycle where we know there are going to be times of plenty and there are going to be times of lack. And so we have to be able to survive the times of lack. So by breaking our metabolic efficiency, by leaving some of the glucose in the bloodstream so it can be used to store fat, by triggering the desire to go forage and all that, all good in a sort of micro moment. Why do they lead to Alzheimer's when the switch is left on?
Yeah, great point. And, I just come back to what Rick was pointing out a minute ago, that foraging, you've got, one of the most common things that happens with Alzheimer's patients is they wander. That's why they put signs on the back of these patients. And what do? They wander off. And you say, what are you doing? Oh, I'm trying to go home, or I'm trying to do this, or I'm trying to do that. Well, this is foraging behavior.
Jesus.
So what happens is that this is very much analogous to the issue of stress that is then resolved versus chronic stress. We all know that you get a little stress, it is hormetic. You actually get this hormetic response where you do better with ongoing stress, and then it's resolved. Then you have some stress, and you're now you're making more stem cells, you're responding.
A little bit of bad is good for you.
Exactly. Now, you do this and you just keep it chronic, which is the big problem, chronic stress. Now you've got hypertension, now you've got neurosis, now you've got all these things. And I think Rick has made a really good point of this, that this is ultimately what Alzheimer's is. Your body has responded to insults. And we've been interested for years in all the different insults. You've got to look at what's driving that innate immune system and where that actually is. That's got a memory that's in your endothelial cells of your blood vessels. It's in your tissue macrophages, so that's the microglia in your brain. And it's also in your bone marrow. So you're now hyper responding to things like COVID-19. And you can drive that up by things like by eating saturated fats, by not having enough polyunsaturates, by salt, all these things. So what we see as Alzheimer's, and this is why it's so relevant for the way how sharp you are on a day-to-day basis. This is the end result of these responses to stress. So we are stressing ourselves out repeatedly over the years with our exposures, with our eating of fructose. Basically, we are driving a system beyond its evolutionary design. We were not made to eat a lot of sugar, and we're doing it. It's just like, jumping out of a window from the second or third story. You might survive a few times, but you do that, 10 times a day for 50 years. You're going to have some major rheumatologic and orthopedic problems. So we are triggering this thing, and unfortunately, that we're actually making, each time you activate your innate immune system, which you can do with fructose, each time you're turning down your mitochondria, just as Rick was explaining, your body makes a little amyloid. What is it there for? It is there to respond to insults. It's really interesting stuff. It coats the bacteria. It actually is antibacterial, antiparasitic, antiviral. It's an amazing molecule. It's actually there to protect you. But part of that, and this is what I was asking Rick about last night, because to me, this is the billion-dollar question. Why is it that your body has brought together the thing that is your innate immune system that is responding to these insults, trying to help you, but it's put that together with reducing your energy and literally downsizing your network? And that is the surprise here, that your body hasn't evolved a way to say, I can get rid of the P. gingivalis or the herpes simplex, another common contributor to long-term activation of your innate system. People who treated their outbreaks in Taiwan had an almost 80% lower likelihood of developing dementia. Just striking results.
How do you treat it?
simple acyclovir, valacyclovir, things like that.
And that works because it's reducing the amount of time that the brain is under assault, basically?
Exactly. So you're reducing the thing that's actually driving your innate immune system to stay on. And I think
do they have to treat that chronically, or is that like if they have a flare-up?
They typically were doing with flare-ups, but yeah, so some people will do it if they're having a lot of flare-ups, they'll do it chronically. So what's happening is you're seeing a system that has defended itself quite successfully. You can see people with massive amounts of amyloid in the brain who are still quite normal cognitively. It's when this stuff is now giving the oligomers, you're taking these big lakes of amyloid and you're now making the oligomers from that. It's a little bit like taking troops and sticking them in a fort. As long as they're in the fort, they're not out shooting and killing the populace. But when you open the fort, when you're now continuing to poke the bear, basically, you're now going to be bringing these things out that are both downsizing and protecting. And your body your brain is making a choice, saying, I've got to fight these invaders, so I'm going to live with a smaller brain. I'm going to live with fewer synapses. And it's the loss of synapses that is the big problem. We're losing our processing speed. We're losing our ability to lay down new memory. And the interesting thing is, this is a program. Your brain is deciding, look, you in your life have done all these wonderful things. You've got enough to live successfully for years. So if you've got to give up something, if I said to you tomorrow, Tom, you can wake up and either have you're not able to store new memory, or you're not able to speak, calculate, do your job, that's an easy choice. And that's the choice your brain is making.
Woof. Okay, so what is going on? That makes it shrink back. It's under assault. I get that. But why is the solution to not form new memory? Is it just resource allocation? It doesn't have the resources, or?
Yes. So you are not, so your supply and demand is now mismatched. So you can put your resources into fighting the pathogens, or that's where the inflammation part comes in. Or you can put it into things like your mitochondria, building synapses, making and keeping your memory. And this is why getting rid of those problems, having the extra virgin olive oil, keeping your inflammation low, keeping your fructose low, these things are all so critical for you to be at your best when you are making and keeping new synapses, making and keeping new memories.
So talk to me really fast about the polyphenols. What are they doing? Are they protective against something, or are they giving me a building block that I need?
Yeah, there are several mechanisms, but they are, to some extent, they're having an anti-inflammatory effect, and they're supporting your mitochondrial function.
What Dale has talked about is that there are probably multiple mechanisms leading to Alzheimer's, and there's infections, toxins. It's known that like a concussion can increase your risk, and genetics, and what I've been saying is that fructose may have a dominant role. Interestingly, fructose could be playing a role in this pathway, like with concussions and toxins too, because the enzyme, the chemical reaction to make fructose, is turned on under on many stressful conditions. It doesn't require you to be, it isn't just diet. So, for example, mild dehydration. Concussions cause low oxygen. It causes what we call hypoxia, contusion. The blood vessels aren't delivering as much blood oxygen, so you get the brain kind of swells a little bit with a concussion. That will stimulate local fructose production. That's actually
why?
Well, because you think of fructose as trying to be a survival pathway. Mm-hmm. So when it gets turned on, what it does is it turns on inflammation to try to fight off the toxins or whatever. It tries to reduce the energy in the cell to conserve. If you have impaired blood supply, you're not getting the nutrients. So to the brain, it's like a starvation state. So what you want to do is you want to reduce your energy needs. And if you stun the mitochondria use a lot of oxygen. And when you stun the mitochondria, your oxygen need goes down acutely. And you're not, everything goes into a low power mode. So you're making less energy, but you don't need you're trying to go into a low energy mode where your metabolism goes down. And it turns, you were talking about how metabolism gets turned down. It isn't just the uptake of glucose, but the enzymes involved in glucose metabolism, fat metabolism, they all get turned down. Everything goes into a low power mode. We're trying to protect. We're under attack. We're going to start inflammation. We're going to reduce our energy needs, and we're going to survive this attack. And that happens with a concussion. May happen with toxins. COVID, actually, one of my friends measured the mitochondrial changes in long COVID. It's the same signature as fructose. We just don't know if the long COVID stimulates fructose, but it's the same signature. The ApoE4 is also, suppression. People who have that, they suppress their mitochondria. They increase their glycolysis. Again, it's the same signature. It's like a survival pathway. So whether or not that involves fructose, I don't know yet. But I do know that fructose activates the survival pathway. It's turned on under low blood flow, low oxygen infections, viral infections, herpes simplex. They may also be able to induce this activation. So it could be one main pathway that is converged on by all these toxins and so forth. And what you're doing is I'm going to look for all these. I'm going to look and treat the infection. I'm going to look for vitamin deficiencies. I'm going to look for all these things that might cause stress. And also I'm going to look at insulin resistance and all these things. And so you are making great roads, incredible achievement to slow down Alzheimer's. And our work is a hypothesis that says that all these things may work through fructose to eventually cause these changes. I'll tell you one thing. If you give sugar water to an animal, a lab rat, after about 4 weeks, they have trouble walking through a maze. They have trouble getting through a maze. Their brain starts to shrink. They get the mitochondrial problems. They get the insulin resistance in the brain. They get the inflammation in the brain, all published. And if you take about 18 weeks, they start getting amyloid plaques, tau protein, in their brains, in the hippocampus. Probably fructose probably can be said to be a cause, excessive fructose, to be a cause of Alzheimer's. I think we could probably say that based upon these experimental data, if you take people who have Alzheimer's and you, at autopsy, measure their fructose levels in the brain, 5 to 6-fold higher than a normal person.
Whoa.
Yeah, that's significant.
And you come back to the switch, just to say, there's a switch in your brain that you've talked about here, but your brain is literally switching. And we see this, we studied this more through the amyloid precursor protein signaling, but it's the same story. Your brain is literally switching from a mode of building and maintenance. We can make new synapses, we can learn new things, we can build new bridges, basically. It's now switching to a mode that is all about protection and downsizing. As Rick said, it's a low power mode. It's saying, tough times could be ahead. We're now going to use our resources to fight potential pathogens, to deal with toxins, but we're going to live with fewer synapses. So that is a switch. And you can see it, by the way, when you study APP signaling. You literally go from cleavage at one site to cleavage at 3 sites. And the
What's
peptides,
APP?
This is amyloid precursor protein, which is the protein that sits in the membranes that is going to give rise to the amyloid, which is a tiny peptide fragment of that overall protein. And this thing is a switch. You can literally go back and forth between this maintenance and building mode into a protective mode. So it fits beautifully with Rick's theory of how this works through the fructose-related pathways.
And the incredible thing is, once you kind of understand this, you can actually design a management plan to prevent Alzheimer's, which you've already done. Actually, what you're doing is reducing fructose production in the brain through all these different measures, reducing high glycemic carbs. Polyphenols, some of them actually block fructose metabolism. There's luteolin and ostol are polyphenols that can block fructose metabolism to some extent.
Wow, this is really coming together for me. So much so that I'm going to I'm going to recontextualize my initial statement at the beginning of this. So at the beginning of this, I said, this is all downstream of glucose. But the reality is, what I'm hearing now is that glucose just happens to be the way that we put our body, brain specifically in the context of Alzheimer's, but it just happens to be the way that we most frequently put ourselves in the I'm under assault, I need to go into low power mode. But the reality is there's many different, let's call it 4 or 5, whatever ways that we can put our brain and body in the I need to go into low power mode, I need to protect, I need to survive this insult. So from a brain perspective, it could be a concussion. From a brain perspective, it could be diet, glucose. From a brain perspective, it could be a virus, could be bacteria. So anything that's going to put our body into that hyper defensive mode where I'm left with the decision to survive this or to make new memories. And when I have to figure out whether I can walk and talk or I make new memories, I'm going to always choose the walk and talk, which is why, and this is terrifying, people with Alzheimer's turn into basically a zombie. And it's like, they're not there, but they're still alive. There, meaning the person that I knew and loved is no longer present. But the reality is that they've just so chronically been in low power mode that everything is offline. Now, you hinted at this and you said it outright at the beginning. It sounds like then there are things that we can do to get out of low power mode. And while I can only imagine that the longer you stay in it, the more damage is done that we're not going to be able to unwind, that we can start unwinding some of this. What does that look like? What would a protocol be?
Yeah, that's a great point. And, you know, the one of the most exciting things is seeing people who've been told that they're going to die, there's nothing they can do, they have Alzheimer's, that they actually get better. And we had people in the trial going from MoCA scores of 18 or 19, which is, this is out of 30, where you have significant Alzheimer's, to perfect 30s, doing very, very well, just striking improvements. And the most common thing we hear is that the spouse says, you know, they're so much more engaged. Suddenly the synapses are firing again and they are starting to interact. So what it looks like is very much what Rick was saying. We are looking for all the different contributors because they are different from person to person. But again, as Rick has pointed out, you could argue that the most common insult that our brains are undergoing is glucose and fructose related. But we do see people where it's about their oral hygiene. We see people where it's about leaky gut, where again, as Rick has pointed out, fructose plays a role. We see people where it is about living in homes full of mold and the mycotoxins, things like trichothecenes and ochratoxin A and gliotoxin. These affect your immune system as well as your nervous system. So there are, as you said, there are many ways to give yourself these insults. And unfortunately, the big problem with this disease and all chronic illnesses is that they go on for a long time before we recognize it. So part of the medical revolution here is for people to do more with things like wearables, where we're seeing, oh, wait a minute, you know, my heart rate variability is changing. You mentioned CGM earlier. So continuous glucose monitoring, great. If you're going off scale, and by the way, we see the other half of that as well. People who are eating high-carb diets go to bed, wake up at 4 in the morning with a glucose of 45. They've gotten significantally hypoglycemic.
Off of a high-carb diet?
Oh, absolutely, because you get the peaks and the valleys. You now get the insulin coming out, and you drive yourself into these into hypoglycemia, which is horrible for your brain as well.
Okay,
so you want to identify those and address. So our protocol that we developed is about identifying the drivers and then
what's causing
addressing the drivers. Yes, so we're addressing the inflammation.
So do you have a standard questionnaire, or is this where we get into the blood test?
We do have a standard questionnaire, and we look at, right now we look at 150 different variables, but ultimately it will be whole genome and it will be epigenome. There's some great tests that are now available that haven't been available before. Phospho-tau 181, phospho-tau 217. These are literally looking at your brain's pulling back, because when you phosphorylate your tau. And tau is like the bolts. If you're building out a piece on your studio, you'd be putting out rafters and then bolts on them to keep them stable. The tau is what stabilizes your microtubules. And when your body is now pulling back, what it does is it sticks a phosphorylation group on the tau, which pops it off and allows your neurites to collapse. So you're literally looking at that, what's ongoing, but you're now looking at it in your bloodstream. You can also look at things like GFAP, which is another blood test. These are all now available. Neurofilament light is another one. And these precede. So it gives us the ability to look earlier, to say, Tom's brain is not doing what it should be. He has to worry 10 or 15 years down the road. So what do we do for these people? We identify what is causing it. Do they have inflammation? And so what we did, we identified, as you know, 6 different subtypes. We say, there are people where it's a predominantly inflammatory disease. And, these may all go through fructose. I don't know yet. I'm fascinated to find out. We see people who have more of an atrophic mode. So in other words, they're just very low in all their supportive elements. Estradiol, testosterone, pregnenolone, progesterone, thyroid, vitamin D, all these things. That gets to the energy component of this. Then there are people that have what we would call glycotoxic, where they've got a high HOMA-IR. They are very insulin resistant. Then we have people who have a toxic, where they're exposed to either biotoxins, inorganics, or organics. Air pollution, as you know, lots of interesting work on air pollution, increasing risk for cognitive decline and for Alzheimer's disease. And then we have people where, as Rick said, it's concussion related. This is where you have traumatic. And many people, it's a combination of those things. These are all insults to which you have responses. So we identify those things, and then if you've got pathogens, we want to get rid of those. And then, of course, we want to heal your gut. We want to give you metabolic flexibility. So you were asking before, ketones. People do better when they have ketone levels above 1.0 millimolar BHB.
How often?
And we've seen at least once per day.
Okay.
And but when we do that, then what we do is, the key is to make them metabolically flexible. So you're in good shape because you're able to go in and out. You're able to use glucose when you need it, and you're able to use ketones when you need it, and you're not having these high levels of glucose, and you're not having the hypoglycemia because you don't have a high-carb diet. So those are all critical pieces to get people metabolically stable, and that's when they do the best. And it's interesting, when people start having energetics, they've got the ketones on board, they're able to utilize glucose again, they start to get better, they start to perk up. And then we have to make sure that their innate system is not being activated. Now, one of the things, as I mentioned earlier, the innate immune system, one of the places it stores memory is in your endothelial cells. So both with COVID and with Alzheimer's, you're ending up with these microthrombi and microinfarcts that over the time really take a toll on you. You see this all the time with the MRIs.
When you say I store memory, what do you mean? Is it a damaged cell or a cell that now reacts in a different way?
So you're literally reprogramming the cell. So it's not necessarily damaged. You don't have to wait that long. You're reprogramming it to be more thrombotic. So you're reprogramming
is
your
thrombosis
cell.
blood clotting?
Yes, you're basically making it so your platelets are stickier. You're not rolling your blood along these nice endothelia the way you should, and so you end up with a higher risk for these microinfarcts. So one of the things we do is to treat that and to prevent people from having these microthrombi. We get their innate immune systems to quiet down and relax.
What do you do to do that?
With things like, well, you bring down for the blood vessels, you can use things like nattokinase and pycnogenol, easy to use.
Are these drugs, supplements?
These are actually supplements you can get.
Over the counter?
Yeah, you can get these over the counter.
Wow.
And then, of
what
course,
are they called again?
So there's one that's called nattokinase, and there's one that's called nattokinase. And you can get it by eating natto. And the other one is called pycnogenol. And I don't, we never recommend that people just go out and try these things willy-nilly. Talk to your practitioner. We've trained over 2,000 practitioners now to do this protocol from 10 different countries and all over the United States. And then for the innate system part, great things like omega-3s. SPM active is a resolvin. So resolvins, discovered by Professor Charles Sirhan at Harvard a number of years ago, very interesting molecules. They are omega-3 cousins, basically, that help you to resolve ongoing inflammation. We now want to tame that innate system, and we want to bring up your energetics. Those are the two critical pieces. And in so doing, of course, we also want to get rid of the pathogens that are causing this to be chronically activated.
Rick, were you about to say something?
Yeah, I was just going to say that a lot of what you're talking about, this, trying to improve the energy in the cell, improve metabolic flexibility, that's exactly what happens when you remove fructose.
Yeah.
So fructose, causes metabolic inflexibility because it's blocking the fat from being broken down to the ATP. It's suppressing the glucose metabolism through the mitochondria. So if you can reduce fructose production or intake, you can theoretically have a lot of these effects, including on the endothelium. I mean, it's just it's really so it grounds me when you talk about your approach, which is a very personalized medicine approach where you're looking at each area and then really trying to knock it down. I can see fructose as a commonality across the board, and my recommendation is that everybody should try to eat healthier. And
define healthier.
And what I mean by that is, because we can show that this pathway is associated with aging too. I have knocked out this fructose pathway in animals, and they stay lean, old, they're smart, they don't develop kidney disease or heart disease or liver disease with age, or it's very mild, and their mitochondria stay healthier. So I think that this fructose pathway is generally a problem that's involved in a lot of diseases, aging, and so forth. So from my standpoint, I would cut out soft drinks.
Because of their sugar content?
Because of their sugar
diet?
content, because they have glucose and fructose. They are concentrated. They have a huge amount of glucose and fructose.
Diet soda okay in your
Diet
book?
soda would not activate this pathway, but it does make you still like sweets. So,
what about fruit juice?
And change
fruit
your
juice, you
microbiome.
should not drink fruit juice, but natural fruits are totally fine because the intestine removes about 3 to 4 grams of fructose, and so you can eat a fruit and very little fructose gets to the liver. And I would say that natural fruits are good because they got all your flavonols, they got vitamin C. Vitamin C actually counters some of the fructose effects. Everyone should take vitamin C, 500 milligrams twice a day. It really, we're going to come out with a paper showing how how vitamin C interferes with fructose. It's really terrific. We should be eating a little bit of vitamin C. To counter fructose. So, cut out, reduce sugary foods. Read labels, reduce high fructose corn syrup, reduce processed foods. They're filled with salt and sugar, ultra processed. Get rid of, try not to eat those. Try to not eat a lot of really salty foods. If you're going to eat something salty, drink a lot of water with it so that it doesn't activate this pathway. Water, when you get thirsty, you're activating the switch.
Talk to me a little bit more about water. So I am wildly ignorant on the topic, but I have a gut instinct. The way that people tell you to drink water does not make sense to me from an evolutionary perspective. We just would not have had that much access to water. So the thought of drinking a liter of water every hour, or whatever the prescriptions are, it seems crazy to me. Am I off track here?
You're off track. Because we're not living in a survival mode right now. We're living with processed foods and high salt foods and salted chips. And back when in the hunter gatherers, they didn't have to drink so much water because they weren't eating all this food with salt in it. We are raising. So when you eat salt, what happens is there's a salt concentration in our blood. And you can measure it. Everybody who gets a blood test when they see the physician, almost everyone will get what they call the electrolytes. And sodium, or Na, is the test for your water balance, your salt water balance. If you're eating a lot of salt but not drinking a lot of water, then the sodium will be high. And if you're drinking a lot of water and not so much salt, then your sodium will tend to be a little low. And a normal range is like from 135 to 145. And everyone said, hey, that's normal. I don't care if the sodium is 144. I don't care if it's 137. But now people are studying it a little bit more. And there was just a big paper. And if your serum sodium is on the lower side, meaning you're drinking more water, so it's like 136 to 140, you will have a much better outlook in terms of lower risk for heart disease, obesity, diabetes, dementia, aging, than if your sodium is like 144. So even though they're in the normal range, the doctors won't tell you this, but there's already data there. The studies are out. We need to drink more water. And if I take an animal and I give them a high-carb diet, they get fat. If I put them on increased water, that reduces that increase in serum sodium, and that is associated with less fructose production. And I can block obesity and diabetes by just increasing water intake. We published it in a very good journal. And so it turns out that these people who are running around drinking 8 bottles of water a day, it's probably a good thing, because what they're doing is they're keeping their serum sodium down, so they're reducing the conversion of glucose to fructose. Because remember, a high salt concentration in the blood stimulates the conversion of glucose to fructose. Uric acid does too, but salt is one of your best ways to do it. So that's why salted French fries are bad. So if you're going to eat French fries, drink water first to bring your serum sodium down, your serum salt concentration down, so that you don't activate the switch when you're eating the fries, because the sodium will go up, but not to the point where it will convert. You know, it's better to drink water in the beginning of a meal than in the end of a meal.
Interesting. You want to lower the sodium before you intake the next round of salt.
Yeah.
Okay, so do you have a prescription on how much water?
Yeah, it all relates to how much salt. You know, if a person's not eating a lot of salt, you don't need to drink a lot of water. Right. If you're eating a lot of salt, or you're working out in the sun and you're sweating a lot, you're going to need salt and water, and you just need to make sure. But here's some tricks. If you look at your urine, which maybe not everyone chooses to do, but really, if your urine, if it's dark yellow, it means that you are partly dehydrated. It correlates. If the urine is totally clear like water, you're overdoing it. You don't need to drink that much. You want it to be like just slightly yellow. You can also go to your doctor and get a serum sodium, and you want your sodium to be like 138 to 140, maybe 142, but you don't want it higher than 142. And that means you're not drinking enough water. You know, and I always put in this caveat when I talk about this, but if you're a marathon runner, you do have to watch how much water you drink, because there are these people who you can intoxicate if you drink gallons of water. And on marathons, when they get really dehydrated, some of them will keep drinking a lot of water, and then their serum sodium can fall, and they can get sick. You can have seizures. And so you know, if you have any concerns, talk to your doctor, measure your serum sodium. But a good rule of thumb is 8 glasses of water a day is, for the average person's really good. 8 to 10 glasses would be about right. We want to have about 2.5 liters of urine a day. Most people have about 1.5 liter. And that would be good.
Where do hormones fall in all of this? Like, as somebody who's rapidly approaching an age where I will very seriously consider TRT, does this play a role in this? Is that one of the things where the body's going to respond negatively where I go into low power mode, or it doesn't matter?
There's a lot of good things about testosterone. I mean, it can raise your blood count. It can sometimes raise blood pressure. It can lower your
Would that be
HDL.
bad?
You know, it depends. If your blood pressure goes up a lot, usually it doesn't raise blood pressure very much. Usually it doesn't raise the blood count that much, but occasionally it can. Usually it doesn't lower, well, it does lower HDL cholesterol. I mean, so there's some negative aspects about it, but a lot of people feel better on it. I haven't really studied it in terms of what it does to fructose metabolism. So I don't know.
Dale, are there any correlations? Because like my next question is going to be, why do women get this at twice the rate that men get it?
So the hormones play a big role in Alzheimer's disease, and that's well studied. Rapid drops. For example, there was a very nice study that came out of the Mayo Clinic a number of years ago where they simply looked at women who had lost their ovarian function. Typically, they, through one reason or another, they had lost ovarian function at the age of 40 or younger. They doubled their risk for Alzheimer's, even though the Alzheimer's didn't announce itself and didn't get diagnosed for many years after that, if you went back clearly. So one of the hypotheses is that it's this precipitous fall. And so, yes, men are less likely than women. Women make up almost 2/3 of the patients with Alzheimer's, just as ApoE4 positive is also about 2/3 of Alzheimer's. And so they are about 65%, as Maria Shriver has pointed out time after time. This is a woman-centric disease. And about 60% of caregivers as well. So one of the thoughts is if you have a precipitous drop in your estradiol and progesterone, you are literally taking that energetic, taking those changes away. And by the way, in our work in the lab, you can literally trace the molecular pathways. Estradiol binds to receptors, estrogen receptors, and that then enter the nucleus and change the transcription of genes. So change the RNA made from hundreds of genes. And one of the ones that it upregulates is the one that cuts the amyloid precursor protein at the good place, that actually gives you the things that say, okay, memory formation, memory maintenance. So you precipitously drop that, and you're paring back on your synapses. People who then go on bioidentical hormone replacement tend to do better with a high estradiol. And testosterone, a similar effect. But of course, when you go through andropause as opposed to menopause, you tend to go down more slowly. And the thought is that may be one of the reasons. By the way, progesterone also critical in detox. What happens, we saw amazing when I was training.
Detoxing from like metals and things like that?
Detoxing from anything that where you're using your glutathione and detox pathways, organics, inorganics, and biotoxins. When I was training in neurology way back in the 1980s, we never saw people in their 50s with Alzheimer's. We thought of it as a disease of older people, 60s, 70s, 80s, 90s. We now know it is a disease of your 30s, 40s, and 50s that gets diagnosed 20 years later.
I thought you were saying we were seeing it in people in their 30s and 40s.
Well, so what we are seeing is one of the most common presentations we see now is a 52-year-old woman, and it's typically associated with menopause or perimenopause. And the current thought is you're exposed to these toxins over time, and you are sequestering them in your bones in various places. You're also detoxing. And then you go through what's called the osteoclastic burst, about a 7-year period where you have dropped your hormones, and you're now releasing some of these from the bone. You're now undergoing the beginning of osteoporosis. Exactly. Now, you don't have osteoporosis yet, but you're releasing these back into your circulation. So you're now exposed to these toxins. And we see presentations all the time with people. And we want to get them as early as possible, help them to detox, get them, they respond very well to bioidentical hormone replacement as an overall part, and then also to detox. And the progesterone is an important player in the detox.
So
walk me through. Sorry,
I just wanted to add to the female question. So it's known that with menopause, when estrogen levels fall, that there is an increased frequency of obesity and diabetes and chronic kidney disease. They all go up, not just Alzheimer's, but the risk for Alzheimer's, but all in general metabolic syndrome and cardiovascular risk all start to increase in the woman following menopause and start being closer to males in many respects, like heart disease and so forth. And there are different theories for it, but one interesting one, in addition to all the wonderful mechanisms you were talking about, is that estrogen keeps uric acid levels low. So in young women, they will tend to have a uric acid lower than men, and that's why gout is really a disease of men more than women. But following menopause, uric acid levels come right up. and become equivalent to the male, and the risk for gout goes way up. And if uric acid, we believe, is playing a role in causing this pathway in Alzheimer's, that fructose and uric acid are working together, one could argue that the increase and the other thing which I haven't told you is that although women are protected, for the same level of uric acid, women show a worse effect. So women have a lower uric acid before menopause, but if you take female cells and male cells and compare them with uric acid, basically, or there's evidence that women are more sensitive and show a greater consequence for the same uric acid. So when their uric acid goes up following menopause, they won't just catch up, they can bypass, in terms of these metabolic effects. So one possibility is that is involved in this Alzheimer's response too, besides the direct effects of estrogen on amyloid and so forth.
And then while we're on uric acid, we should mention the excellent book by our co-author and friend, Dr. David Perlmutter, called Drop Acid. Excellent book.
So, I had him on to talk about that. It was the first time that uric acid really got put on my radar.
Yeah.
Let's keep pushing on uric acid. So what role is it? Is it the ambulance at the scene, or is it actually driving the problem?
Well, most of these things, and I would definitely defer to Rick. He is the uric acid expert. But these things are mostly biological signaling is often in cycles, just as he was saying earlier. It's because it's changing mode. You're literally changing. You're switching from one mode to another mode. So it is both. It is driving it. But again, I would defer to Rick. Are we talking about
U, where it's like it's helpful in the beginning? I guess that wouldn't technically be a U, but basically it's good in one circumstance and then it's terrible in another.
Yeah. So the way that we kind of looked at that was we were curious why humans have higher uric acid levels, and so as I mentioned, most animals have an enzyme called uricase, which degrades uric acid. So most mammals have a uric acid of like 1 or
they produce it, but they get rid of it.
Yeah, they produce it and they get rid of it. And we lost that enzyme 15 million years ago. So just as when I was studying Alzheimer's,
we live a long ass time. Like when I think about us compared to most animals, not all animals, but most animals, we live longer. Obviously, we've become the dominant apex predator.
Right.
So did we lose it or did we get rid of it?
We got rid of it.
Like in a good way, I'm saying.
It was a good way back then. And so let me try to explain how that works. So scientists now can figure out when a mutation occurred. And the mutation occurred around 12 million years ago. And so I was wondering, well, where were we as humans 12 million years ago? And this is actually pre-human, when there were ancestral apes that were they were the ancestors for not just us, but for all the great apes. And I found out that these apes had originated like around 20 million years ago in Africa. And they were in East Africa, and they were frugivorous, meaning that they ate fruit. They lived in the trees, they lived off fruit, and they were very successful. And, within a few million years, there was like 20 different species of ape. Today, there's like 4 or 5 apes, or 4 species or whatever. And then what happened was there was a change in weather, and global cooling began. And the poles increased with ice, and the sea levels fell. And so it's sort of opposite is what's going on today. And Africa was actually an island. There was no connection with Europe. But as the water levels fell, a land bridge formed that allowed animals in Africa to migrate into Europe. And lots of species migrated: elephants, rhinos, anteaters, and primates, these early apes. And they ended up in Asia Minor and in Europe. And it was still warm enough that there were fruit trees all year round in those areas. And so the apes didn't have to change their diet at all. It was still the same. And then global cooling continued, and in Europe, those fruit trees started becoming less, and there was a change in the forest, and suddenly there wasn't a lot of fruit during the cooler seasons, sort of like the winter, but it wasn't true winter. It was just a cooler period of time. And the apes started to starve, and you can show that by skeletons that show that they had these striations on their teeth that kind of look like tree rings, and they call it enamel hypoplasia, and you get it during the growing, when the teeth are growing, and it gets stunted when there's no food around. And there's a very famous anthropologist named Peter Andrews who was at the Museum of Natural History in London, and he was studying these apes. And I figured, I don't know much about archaeology myself, but this guy does, and I'm going to go talk to him. So I flew to London, met with him, and he showed me all the work he did, and we spent quite a bit of time together. And I said, could it be that this mutation may have occurred in the apes in Europe? He says, well, let me try to explain to you what happened. And he said, our work, we looked at the skeletons, and we realized that it was a European ape that became our ancestor. And the European ape, when they were starving, they didn't all become extinct. Some of the European apes actually migrated back to Africa, but when they migrated back, they overcame the apes in Africa, and so they came back because when they started to starve, they had to come out of the trees. They had to learn how to walk around, not bipedal, but more like knuckle walking. They had to learn how to dig up tubers and roots and eat different foods because there wasn't enough fruit around. And that was when the mutation occurred. And it turned out that when they came back, some went to Africa and some went to Southeast Asia to become the orangutan. And they all carried that mutation, showing that they came from a common animal that we think was in Europe. So we realized that maybe that mutation may have helped them survive when all the apes were becoming extinct up there. And it might have allowed them to make more fat from fructose. So what we did was we took a mouse, or a lab rat actually, and we inhibited uricase. So we made it like we didn't mutate the uricase, we just inhibited it. And its uric acid went up, and then we gave it fructose, and we gave another group the same amount of fructose, but without inhibiting the uricase. And the animals where we inhibited uricase were much more sensitive to sugar.
That's really interesting from a calorie perspective.
Their blood pressure went up more. They got more fatty liver, even though they're eating the same amount of fructose. Exactly. And weight gain is driven by calories, but the rest of it is not. So the blood pressure.
What are you calling the rest of it? Sorry.
Insulin resistance, blood pressure, fatty liver, all those things are independent of.
So they would get fatty liver without putting on fat?
Correct.
Interesting.
Oh, yeah, absolutely. And then I worked, there's a guy named Eric Gauscher who's a molecular evolutionary biologist, and he actually resurrected the extinct gene that we lost, and we could put it into cells, and we could show that when a human liver cell has uricase, it makes less fat from the same concentration of fructose. And if you take a human cell today that does not have the uricase, it makes a lot more fat.
Do you inject the uricase?
We transfect. Yeah, we express the gene in the cells.
You can turn it back on. How are you turning it back on?
No, we resurrected the gene by figuring out what the gene was, and then we made it and put it into a liver cell.
I'm saying, how are you getting it into is this a cell in a petri dish?
Yes.
I see. So not a human who is alive into their active liver cell.
But what it does suggest is this mutation was to help us survive, because the mutation, what it did was it raised our uric acid so that we could make more fat from fructose, because fructose makes uric acid. And if you start off with a higher uric acid and you eat fructose, the uric acid that's produced by the fructose goes up even higher. So for the same dose of fructose, the uric acid goes up much higher, and you get a much bigger switch. So it's really interesting. If you take a mouse and you give it sugar, you have to give it a lot of sugar to make it fat. But humans are much more sensitive to sugar. And this is one of the reasons.
Wow. Very, very interesting how this all comes together. So, Dale, go ahead. You were going to say something.
So I was just going to say, so my interest is, okay, let's imagine that this is going to be the major player, that fructose is going to be the major player, and pharma is going to go out and develop an inhibitor, prevent this pathway. Very little that the human body does that is to give it disease. It's responding to something in a hopefully positive way, just as you've just explained with evolution. So my question is, what's going to be the side effects? What do you lose by losing this when pharma comes up and says, okay, okay, professor, we've now got something that looks really good and it's going to help Alzheimer's disease. What are going to be the side effects of that drug?
Well, there are actually people who lack the enzyme. And it's pretty rare because they don't have any symptoms, so it's hard to find them. But the few kindreds that have been found, they don't develop type 2 diabetes, they don't develop obesity. So
have we looked at longevity or anything?
Yeah, they haven't looked at longevity. But the belief is that it's pretty innocent. And
in a modern context, because I can tell you the out in the wild perspective is you starve to death and die. So in a moment of famine, you're toast. Whereas myself, I can make 7 pounds of fat out of 9 calories. So it's like, I'm going to survive a famine, guaranteed.
Yeah, so exactly. That would be my prediction, is if there was like a serious famine, they're not going to do as well if you block fructose metabolism. Then, but in
a modern context where you can go to the grocery store, not so bad.
Yeah. They might live longer. The prediction would be they would live longer. So I think that so long as, we have grocery stores filled with 20,000 different food items and people will continue to pick the foods that they want, sometimes even when they know that they're not good, it might be a beneficial thing to have an inhibitor.
Wow. Very interesting. Okay, so just to bring this all back around, if you have diabetes, you need to figure out, not diabetes, if you have Alzheimer's disease, you want to figure out why you have it. What is the insult that's leading to this, whether it's a toxin, whether it's your diet, whatever. But you need to figure out what it is, and then understanding that basically all of this is kicking off this switch. You're turning on the fructose, either you're intaking it or you're producing it. But either way, you've got a fructose production problem in the brain that is causing you a problem. You're going into low power mode. Everything is shutting down, retreating. But you guys are the first ones to give me any hope that there's actually a way back out of low power mode, and you can actually see a reversal of these symptoms, which is absolutely extraordinary. What is the next step in the research? Where do we go from here?
Yeah, critical piece here is that when you develop Alzheimer's disease, you go through 4 stages. So you have a pre-symptomatic stage, often in your 20s and 30s, where you can already pick up changes on PET scan. You can already pick up that signature we talked about earlier with temporal and parietal hypometabolism for glucose. Then you go through a period that lasts on average 10 years, which is called SCI, subjective cognitive impairment, where there's something wrong, but you're still able, by definition, to test in the normal range. And this is the problem. The doctors are telling you, you're getting a little older. It's nothing to worry about. Well, a lot of people who get older have problems, but they shouldn't, and that's the key. If everyone would just come in at those 2 stages, either get on active prevention or earliest reversals, we could make dementia a rare problem today.
Wow.
The problem is everybody's coming in on the last 2 stages. The 3rd stage is called mild cognitive impairment. Terrible choice of terms. It's like telling someone, don't worry, you only have mildly metastatic cancer. It is a late stage of what is going to become Alzheimer's-related dementia, and dementia is the 4th stage. And by definition, that means you've begun to lose your activities of daily living. And even in our trial, we took people with MCI and early dementia, and even then, 84% of them improved. But if you could get people early, you can get it closer to 100%. So I think the next step is to go after, first of all, to understand whether this is present in all the other things when we're seeing the other pathogens. Is this all through fructose? And then I think This is maybe an excellent pharma target instead of trying to remove the amyloid, which really is a naive approach and makes no sense by itself. Let's try to shut down the actual drivers of the decline. Again, I'd like to remove upstream what's actually causing it. If you're living in a place that's exposing you to things, you need to address that. And as we've heard today from Rick, quit eating the fries, quit getting all that salt, we now understand what are all these things that are driving this pathway that may be so common as a critical pathway for developing cognitive decline.
Amazing. Where can people follow you, Dale?
You can look at drbredesen.com. The Facebook is Dr. Dale Bredesen, and same for Twitter and Instagram. And then we have a couple of books out. The End of Alzheimer's, talking about these sorts of things. But of course, at the time, we didn't know about fructose until Rick's exciting work. And then a more recent one, The First Survivors of Alzheimer's. Tremendous 7 stories from people who got better, and they talked about what they went through.
Amazing. Rick, where can people follow you?
Yeah. So drrichardjohnson.com is my website. And I have a book, Nature Wants Us to Be Fat, that includes a discussion about Alzheimer's and the foods that activate this switch. I also have a Twitter account that's very similar to my website. And Instagram is Dr. Richard J. Johnson. So I do want to say that to end this by saying that Dale's work actually has hands-on proof that this kind of personalized medicine approach works. Our work is compelling, but we still have to we have to take it from the hypothesis and compelling out evidence to actually try to prove it. And so we still have more to do. But I will say that I think there's enough evidence that people need to view diet as one of the most important things. Diet and exercise, following all these general rules that you have been doing and others have been doing of, trying to reduce high glycemic carbs and sugar, reduce salt, drink more water. I think that there's enough evidence there that, this should be something everyone should be doing in trying to stay healthy and reduce their risk for Alzheimer's. So.
I love it.
Okay.
All right, everybody. Remember that ultimately you are in control of what you do, and it all has consequences. And speaking of things that you should do, if you haven't already, be sure to subscribe. And until next time, my friends, be legendary. Take care. Peace. Click here to learn exactly what you need to do to prevent Alzheimer's disease and even potentially reverse it.
This woman in front of me, my patient, her life is decimated now. Her life is decimated now. She's in my office week after week, sobbing